Forced migration is a topic that is in the news all the time, unfortunately, with the events that have happened in Syria, Ukraine, and now Sudan. I'm going to talk about my model that I've created. The model is a little bit different than what you've seen the last day and a half, where it's a different scale. The model is a system dynamics model. So it's unique. I don't see anybody else on the schedule with that model. It'll give you a chance to see something new and hopefully give you some inspiration to try out system dynamics. It's a different approach that can be used for complex modeling. This is the agenda that I have for this morning. Just a brief intro, talk about the methodology, the data sources that went into the system dynamics model, talk about the model itself, the two parts of it, and go through the results, discussion, and conclude. What you see over here is an example of an infographic that our division creates. So the infographic is a fusion of information. Within this infographic, we can see that there's displacement within the country of Sudan, as well as displacement outside. So just a little bit of terminology. Refugees would be the folks that are forced outside of the country, and IDPs, or internally displaced persons, are within the country. So there's different symbology shown here. And forced migration is a very complex topic. I spent several years studying it for my PhD, and decided to delve into it a little bit more with data science. So I had a little sidetrack there to learn more about programming, and systems dynamics gave me a new method to simulate the processes that are going on with conflict, with regime stabilities. So it's a very nice model that you can have for data that is very difficult to collect. A lot of the data comes from authoritative data sources. But those authoritative data sources are oftentimes slow to be published and put out there. So there is a new paradigm that I've found with working with forced migration. So there's a lot more open source data that are out there now. I'll get into that a little bit later. With forced migration and migration in general, that's becoming a very large influence on demographic components. There are record numbers, unfortunately, with the forced migration, up to 80 million and more. The population numbers are increasing in migrant-prone countries as well. The motivation behind this research is there's a new paradigm. So migration is not a new issue. People have always been moving places to places or been persecuted. Now, what is new is the amount of open source data and social media data that is out there. So that you didn't have access to that before. These social networks that allow for people to find out more information from trusted sources. So there's been an emergence of open and crowdsourced data where we didn't have that information before. We would have to rely on UNHCR or IOM data sets, government data sources that could take several months or even years to release and be available publicly. Now you can access that data within a few hours, days, and within the model, I found that I was able to aggregate that to have a common time series. The topic has relevance to both regional and national security, and this can provide new insight to how people are moving or forced to move. With system dynamics modeling, you have systems thinking. So these are a couple neat figures that have been created to illustrate the system dynamics thinking behind it. So instead of having different points or data sets that are disconnected, you have an interconnectedness with system dynamics and systems thinking. Instead of being a linear process, you can have circular reasoning within there, feedbacks, positive feedbacks, and balancing feedbacks. Instead of having data that is in different silos, you can put that data together, and there is emergence of information that exceeds those individual silos. And those parts, once they're combined, you'll see with a causal loop diagram that I have, there's a lot of relationships and how these factors are connected with stability factors and instability factors and how those can influence one another. And with the analysis, instead of having points that are just run discretely from one another, set distances, you have a synthesis of data sets that can combine to create something larger. And there's relationships. Instead of treating all your data as isolated data sets, you have relationships that can be explored. There's a lot of prior work within looking at forced migration, quantitative studies that looked at statistical modeling, regression, and binomial regression, pooled regression. So a lot of these were delving into the quantitative aspects of forced migration. And what I found in my early research back in 2015, 2016, there was a lack of system dynamics models that went in to explore the data. Well, it just really wasn't there. So that's where I started to see that I could use open source data to supplement that, to have a proxy information to look at the issue of forced migration. So these are some studies that have been published over the last couple of years. When I went through to find data sets, this took a long time to curate and explore the data sets, and that's what led to a second master's in science of data science, just exploring and looking around and seeing how I could use the data sets and delve into them. I found that these data sets provided a good proxy to look at how conflict, regime, forced violence, socio-political mobilization, and intervening opportunities can influence the forced migration of people. So you have a push-pull dynamic that is reflected within migration. The push is the violence. Human rights violations, that's one of the largest push factors that are out there for migration. Intervening opportunities, that's a difficult one though. Intervening opportunities is how you can make things easier or more difficult when people are being moved from one location to another. So for a proxy of that, I used weather to see how that could influence the displacement of persons. And to bring in a reinforcing or a balancing effect, the contact rate. You can think of this as your word of mouth in a traditional system dynamics model. So these are the different data sets. Now, with populations, this really fits with the stocks and flows of system dynamics modeling. So you have the potentially displaced persons and then the people that are displaced as well. So the total population, those are some authoritative data sets that are out there, World Bank, for example. And then the displaced persons that were calculated in my model or are created as a prediction. Some of these data sets I mentioned before, they're authoritative, but they're very slow to be released. So an example is the UNHCR data set. It could take months before you can figure out how many people have left a certain country. They do get into displacement statistics, and with migration and forced migration in particular with refugees, there's a problem of categories. So each country can treat refugees as a different definition. So it's very complex. This shows some of the data sources with how the people are moving and within over periods of time by the month, as well as a chord diagram where people are moving from and to. So these are just some of the authoritative data sets that I use to compare with my model and help, so you can think of it, train the data and figure out how the model should be modified. With system dynamics model, you have a causal loop diagram. So you can think of how those relationships are working with one another. So within the conceptual model here, I have stability factors and instability factors. So you have positive and negative influences that are just shown here with the causal loop diagram. The arrows, how they're related to one another, and the polarity, whether it's positive or a negative in the change of that variable. If you have more increased regime force violence, there's going to be increased human rights violations. Or if you have increased civil war, there's going to be increased human rights violations, potentially. If you have a regime legitimacy that increases, that's going to hopefully have a decrease in the regime forced violence. Okay, so this is just a causal loop diagram. With the system dynamics model, this is a very simplified flow. So they have your stock, which are the potential people that are displaced, and the new stock, the forced displaced people. You can have parameters, those are your set values in there, and you can have variables as well that influence that flow rate. So you can think of it as turning on a spigot and the flow of people within the forced migration case study. You also have reinforcement within system dynamics. So the reinforcement of a variable, such as contact rate or word of mouth, can increase that effect, increase the flow rate. Within the model, I had stocks, flows, parameters, dynamic parameters, table functions, and charts that were included within the system dynamics model. During the creation of the model, one of my dissertation members wanted to have a place to be able to modify that. You could think of it as different levers. So if you wanted to increase conflict or decrease regime stability, you can pull these different levers and see the effects within the model. So this makes it very dynamic. The goal was to publish and push the model out to AnyLogic, which is where it resides. There's a link in our second published paper that has the link if you want to explore it. This is the model that was created. There are two parts of it. The first part of the model is looking at internally those different variables and parameters that went into the conflict, the regime stability, the intervening factors, and all those factors that were combined to push people out with the forced migration. Let me make that a little bit larger for you. Within the second part of the model, that's where they're going out to the various adjacent countries, or even countries that they had to transit other countries. So within this model, we can see within the graphs, and you can then analyze the different data sets that are created from it, how many people are being displaced into those neighboring countries. I'll get into that methodology for looking at the displacement into other countries a little bit in 2 or 3 slides. We also have the comparable refugees counts versus the authoritative number, as well as the declining population within the certain country that we're looking at. Within this model, another request from by my dissertation committee was, what if you closed the borders to have an effect on a policy? How could you reflect that within the model? So I have an event for closing those borders, and you can think of that as turning off the faucet for the flow of people. Now, items that I haven't incorporated into this model that would be useful in the future would be returning refugees. I think that would be another area where I could expand this model out. And then looking at, if you do close a border, what additional pressure is felt within the borders. So I think that's something that hasn't been included in here, but I think that's an area where I could explore later on. Within the methodology, we had the stock from the potential displaced persons from the World Bank or authoritative population data source, and then the rate of flow based on the different variables grounded in forced migration literature. So I spent about a year or two in a literature review trying to look at all different causes of forced migration, and it really came down to root causes, such as poverty, the economic conditions. It could be potentially climate change. We could have proximate causes. Proximate causes are causes that are closer to that migration event. And then a trigger event, that is, you can think of that as a straw that broke the camel's back. And it is a triggering event for the forced migration. So the conflict, war breaks out. Within the system dynamics model, within AnyLogic, you can bring in different data sets that were contained within a database table. So I aggregated all these about 5 to 6 different data sets that were aggregated to a month timeline, and then they were comparable. So the data sources were from open source data, and it varied on temporal resolution as well as spatial resolution as well, but I aggregated it down or up to a country size data set for this application. The results, it produced comparable refugee counts to authoritative data sets. In this particular case where we published, it was the simulation ran from 2012 to 2018. There was calibration that was incorporated within the model. The calibration was looking at the different root causes, proximate causes, and seeing how that could be calibrated to acquire the similar results and counts as the authoritative data sets. The model incorporated feedback, a contact rate, to increase the flow, so the word of mouth using social media. There were delays built into the system as well, and events such as the border closure, where you could have it interactively close down. So here's the model that you use, the entire model as you see, and it's been uploaded to the AnyLogic site where you can play around with it, play with the different levers. You can set your own population, the potential population, and see how it runs and modify the conflict. When I went back and compared that to the UNHCR numbers, it got to R squared of approximately 0.92, which was very highly correlated. But there were a couple areas where the model undercounted populations, which I wouldn't have expected. So that led me to look at a couple of data sets, and it was most likely the intervening opportunities, the weather data that was incorporated. So that having a longer time series instead of having an annual calculation or a set parameter would probably fix that. With the border closures, you can interactively shut down the borders. That's what's seen here, and you can look at the database results that show the decreases in flow when you hit that event. So you can interactively close that down and see how it affects the population counts, the people that are potentially going into other places as well. With the route to the other countries, this was based on information such as the openness of another country to refugees, or the number of refugees already present within the country, and the distances as well. So it's built into the routes that were established. And for the calibration, I went through and calibrated based on the authoritative data sources to find different ranges and then have a default value set for that model. To also see how sensitive the different variables were, and performing extreme tests as well. So looking at sensitivity, extreme tests to see, well, does that break the model? How does that affect the counts that are calculated for the prediction? And then finally, with the results, I went through a process of verification and validation. So the verification was just looking at the different units, making sure that they fit between one another, logical checks within the system, and looking at the dependencies and relations. And that causal loop diagram was really helpful for going through and making sure the model was reflective of what the different causes are, the root causes, proximate causes, triggering events, etc. It also looked at the validation, both the structural and the behavioral. So making sure that they were relevant variables within the forced migration literature, and then behavioral, seeing how they interacted with one another. And if one change, such as conflict, really had a difference, and what was the sensitivity for changing that. Within this study, there's several contributions. It ended up having 2 publications with co-authors on this. We came up with a new typology, so it's just good timing. A lot of open source data that's out there, and being able to create the model. And there were very diverse data sets, and there are even more data sets out there. For armed conflict, the ACLID data set is a very good data set that's out there. And then Conflict Observatory, that's in another initiative with the State Department. Started with Ukraine, now it's also a Conflict Observatory for Sudan as well. So within forced migration, there's a new typology of having open source data. And this can be incorporated with a system dynamics model. And over on the right, you can see the different root causes and proximate causes, intervening factors, and trigger events. This is based on the forced migration literature. So in conclusion, open source data was very useful for creating a model for having more accurate predictions. Even other organizations, authoritative organizations, their predictions can be off by several 100,000 people. And when you're trying to plan for contingencies and meeting them at a neighboring border with resources, that can make a huge difference for your planning. That's why it's good to have more accurate numbers. And the simulation modeling can really help when it's difficult data to come by. So system dynamics modeling was a very good and useful tool for looking at forced migration. And I do want to thank the co-authors and my dissertation committee for their guidance through the process, and having me really look into digging into that data. So Ari Croteru and Andrew Crooks as well, from Buffalo, and Ari from George Mason. And thank you all.
Thank you, that was really interesting. I was wondering if you thought about modeling not just on the flow side of refugees out, but if you thought about exploring further the dynamics and things that might affect the flow into the separate countries. I'm thinking about, for example, European countries where we've seen them go from being extremely welcoming of refugees to being far less welcoming over time without actually closing their borders or perhaps changing policies. Have you thought about expanding the research there in any way?
So that is a very, very good question. And that I think that is another dissertation or potential article for publication. That is an awesome idea to see how that policies change over time. And I think there's such a growth potential with using system dynamics modeling for looking at policy. And that's why I'm really psyched that I ended up at the State Department, and I'm trying to help and increase their quantitative analysis and using more data science and data-driven tools to help with the Secretary's efforts for data for diplomacy. It's an excellent suggestion.
Great talk, thank you. Right here. Thank you for a great talk, and it's really great to see AnyLogic being used to address humanitarian cases. My question is, what are the key decisions that this model will be used to influence? And specifically, I'm interested to understand if it's going to be influencing staffing level in the State Department around asylum, because I'm aware that the queue for asylum right now is very, very long, and I wonder if this type of modeling will influence the agency to kind of change their staffing level. Thank you.
Yes, thank you. That's the goal here. Yes, with the State Department, it's a very large agency. So it's about 80,000 people with the State Department. About half of that is locally employed staff. And once you look at there's a mix of government civilians as well as foreign service officers. Those folks are within a lot of bureaus. There are a lot of bureaus that are functional bureaus and regional bureaus. The bureau that really looks at this issue is the Population Refugee Migration, PRM Bureau. So that bureau, as well as CSO, Conflict Stabilization Operations. So working with those groups, that is how these tools can really shape how we work with the policymaker. So one of our division's responsibilities is to brief senior policymakers from those bureaus. So we can give them the information and then incorporate as much of that from open source reporting, all source intelligence to help guide them through the issues.
Well, thank you for showing a little bit of system dynamics that is not always shown in these conferences. And I wanted to ask you about the CLD you have, because it's always interesting to discover like all the process of going through the literature to experts and trying to understand how you can conceptualize such a difficult problem into a CLD, and how you validate that in order to be able to start the model, to building the model. So can you talk about the process you went through to understand the whole thing?
In my research, I went through probably 800 to 900 journal articles trying to pinpoint any relation to migration, forced migration, using open source data, big data. So I used an awesome tool, Zotero, to help organize all that literature. It's a tool that was created at George Mason University. So it's a great way you can find a PDF from any of your library sources, bring it into Zotero, and I use that to help organize and provide like the mental framework for going through, looking at the different migration issues that are influenced by other factors, by conflict, by looking at data sets that are out there, methodologies. So that's how I went about trying to create the framework to look at this issue, because it's a very large issue, and for quantitative modeling, there's only 20 to 30 sources that are out there that really delve into the root causes that are central to forced migration.
Hello, to your right, I guess, over here. A great presentation. This kind of reminded me of my first project when I joined graduate school. Professor Dr. Dietz from Purdue was like, hey, build a refugee camp so that we can process additional folks, and based on the headcount and the equipment that we have, let's see how much throughput we can register those folks and help those that are in need. I'm just curious, you talked about the migration pattern. I'm just curious, like, does the State Department is working on some kind of a simulation work for refugee camp operations. During the initial study, the concept was called RHRC, Regional Hub for Reception Center. And the conclusion of the study, majority of the time, concept works, but execution doesn't. So, for example, Region A has a conflict, a lot of migration happening in that area, deploy plan ABC. A will go well, B won't, C cannot happen. So I was wondering if there was any mitigation work that are being done to, kind of oversee these patterns and execution as well, instead of just looking at the movement pattern.
Operationally, this is where USAID comes in. So USAID is another part, you could think of it as like a joint strategy within the State Department. So PRM works hand in hand with USAID, BHA. So that is the bureau within USAID that looks at the humanitarian assistance. So operationally, that is how like the lessons learned would, and how resources are deployed, and working with NGOs and other organizations to help in response. So it's a multi-effort from multiple bureaus. I think I am out of time. Thank you very much for your questions. And if you have any additional questions, see me after.